Hello, Rasa developers. It's our pleasure today to introduce Jarvis, a multimodal conversation AI framework. Let's introduce our team first. My name is Alex. I do product management here at NVIDIA, and my main focus is around Jarvis and multimodal conversation AI. Today, joining with me is my colleague Nikhil Srihari. Nikhil, would you like to introduce yourself as well?
Hi everyone, my name is Nikhil. I'm a technical marketing engineer for deep learning software here at NVIDIA, and I work with Alex currently on Jarvis.
Thanks, Nikhil. So by the end of this presentation, Nikhil's gonna walk through a demo where he created using Jarvis components and combined with Rasa Dialog Manager and NLU to create an application. So stay tuned. Now let's walk through what Jarvis is. So Jarvis was announced about a month ago at GPU Technology Conference. And then during this announcement, we have a demo where our CEO interacts with this range output. Her name is Misty. Now I'm gonna show you a demo of the interaction.
We've created a demonstration we call Misty, our first interactive 3D chatbot. Hello,
Hi, I'm Misty.
how are you?
I'm doing well, thank you for asking.
What are you here for?
I'm here to give you the latest weather information around the world, tell you interesting facts about meteorology, and keep you company.
Should I bring an umbrella tomorrow?
It is not expected to rain in Santa Clara, California tomorrow afternoon.
What is the hottest city in the world?
The hottest city in the world is Mecca, in Saudi Arabia, where temperatures can reach 122 degrees Fahrenheit.
What is the coldest city?
The coldest city in the world is Yakutsk in Russia, with temperatures around minus 40 degrees Fahrenheit in the winter months.
Tell me something about lightning.
We see lightning first, because light travels faster than sound.
How come you know so much about weather?
I know the weather information from the internet. I have lived for a long time and have been talking about the weather for as long as I know.
Where are you from, Misty?
I'm from a place called Omniverse.
Who made you?
I am created by the wonderful scientists of NVIDIA.
What powers you?
I'm powered by NVIDIA GPU and the CUDA neurons inside of them.
Thank you, Misty.
Thank you, it was a pleasure talking to you.
Great. I hope you enjoyed the demo as well. A couple of the highlights I'd love to walk you through. First of all, is if you have noticed the demo, the interaction between our CEO and Misty is very much like real time. Very low latency interaction. That's very important for the end user experience in a conversation AI application. And the second of all is domain specific knowledge. Now, here we use weather as one example, but we meant to inspire other applications around domain-specific applications for industries such as finance, healthcare, retail, etc. So how do we build tools to enable developers to easily incorporate their own domain knowledge while have such an interactive experience? That's what design take us to this path. Now again, looking to the entire industry ecosystem of conversation AI, it is indeed transforming every single industry from video conference, call center. How do we use AI to empower our call center agent to be more productive? And the smart speakers has been part of our daily lives these days. And fast forward a little bit, in the future we can envision, for example, retail robot guiding us through our shopping experience, an in-car voice assistant that will ride in your autonomous driving car to enhance the driver experience. Now, all of them requires the whole ecosystem to build tools, application together to take this initiative even further. And where NVIDIA is at, we would like to enable the whole ecosystem as much as we do with our compute hardware. Now we do so leverage our GPU hardware expertise to build on top of software to enable the whole ecosystem, be it end user developers from each enterprise vertical or libraries such as Hugging Face, Fast AI, Kali, or computing infrastructure that from cloud infrastructure as well as to on-premises and also on the edge to further take the entire ecosystem of efforts forward. However, As you're very familiar with the conversation AI technology, and especially if you develop a speech-based virtual assistant, you understand the challenge. Here we're talking about not only accuracy, but once you deploy that in the production system to ensure high throughput while have very low latency. And the entire pipeline is also complex, from speech recognition, natural language understanding to text-to-speech. There are a lot of neural models in this pipeline. And then we need to ensure to deliver perceived latency be it less than 300 milliseconds to ensure the end user experience to be natural and interactive. That's extremely hard. On top of that, if we would like our interaction with our virtual assistant be even more natural, so we could actually add on another dimension, another visual cue to engage with our virtual assistant rather than using wake up to engage it every time. So multimodality, that's another functionality Jarvis is envisioned to help developers to achieve by integrating computer vision with speech and dialogue systems. For example, on the right-hand side, you can imagine you shop at a store and you can simply ask the helper robot on the back, what is this? How much is this? That this is very highly context driven because a robot needs to understand where you're pointing at through pose estimation and then do object detection to detect where's the object, and then transcribe the question, does the slot filling, intent classification, and then text to speech to send you the answer back. Typical challenges associated with this application. For example, we hear developers say, hey, how can I use my own data set and own my own model architecture while running everything on the infrastructure as we prefer, be it on premises, on the cloud, or on the edge? And when we do deployment, there are various latency and memory footprint constraints. And how can we scale up and across to support many clients across different servers? Also, for the models, I'd like to have the most accurate possible models. And but at the same time, I would like to have my models to have this extremely low latency and a high throughput. On top of that, how do I integrate multiple sensor and does all orchestration? Those are all hard questions, and Jarvis is here to help the developers overcome this series of questions from, first of all, enabling a developer to start from a base model, and then you can either choose to train your data on your own infrastructure and then or fine-tune those data sets as well. And also once you do deployment, we leverage a microservice approach for Kubernetes, and then we provide a simple API in the form of a gRPC endpoint, so any software developer can integrate that with your workflow seamlessly. On the right-hand side, we leverage our expertise on GPU and fully optimize the entire pipeline so that we can reduce the latency as much as possible and at the same time to increase the throughput to support, for example, a maximum concurrent user of 10,000 users. And then at the same time, we tap into the industry research to get the cutting-edge research models directly pipeline cutting-edge research to Jarvis for production. And then we emulate how robotics implement different sensory functions. We implemented multimodality sensor fusion to help developers manage the complex challenge to integrate different sensory input streams at different time stamps. Now let me walk you through a use case. Let's walk from right to the left. This is use case called video transcription, where in the video you have different speakers, and the goal is to get a multi-speaker transcription that knows who's the active speaker and speaks at what time. So you're introducing two data streams. One is audio, the other is of course video. Now in the middle layer, that's what the Jarvis is. So let me walk you through different decks. In the middle section here, Jarvis has single modality AI services from speech recognition, both streaming mode to reduce the latency and also batched mode for offline transcription, text to speech, the same as well, streaming mode and also batched mode. There's also natural language understanding tasks from high level intent classification, named entity recognition, all the way to more atomic levels such as classified text and classified token. A series of user-centric computer vision services that you can integrate to engage with your dialogue managed system, such as emotion classification, gaze estimation, head pose, body pose, etc. Now, to enable the multimodality feature, we also included these components, these building blocks for you. We have, for example, Multimodal Vision and also Sensor Manager and also Dialogue Management System to help you manage the entire more interactive experience by leveraging both computer vision as well as speech services. So we also shared with all the developers a couple of sample application. For example, multi-speaker diarization in this case, look to talk, and also a very classic virtual assistant based on speech sample application. Now, Jarvis is designed for production system. That being said, we also take into account the challenge of serving inference models across different servers and supporting client request. So we leverage Triton Inference Server, which is designed to help developers to manage serving models across different servers at different client request. Now, another typical challenge that we hear developers say is, how can I further train on my model and then use my own data set? So Nemo, for example, is public available on GitHub, and one can train or even fine-tune their model in Nemo and then seamlessly export and deploy into Jarvis for inference serving. So we designed the entire process from training to inference serving in a very seamless one-stop shop, so that way it's to ease the development flow. Also, we have improved the entire pipeline so much so that we can reach an interactive response where means speech recognition, NLU, text to speech, and also interaction with dialogue manager be under 300 milliseconds on a V100 GPU versus other hardware platform where there will be a much longer response. Now, we also understand that developers don't necessarily have the enough compute infrastructure when they started their conversation AI development, nor do they have enough data set. So we understand that and also shipped all the models to Jarvis. If you add on all those models in terms of compute hours, it's about 1,000 hours on our compute infrastructure. And then also all the models are being trained on either public and private data set. Jarvis today, we have been announced and we're in the private beta stage. So if you're interested to try out Jarvis, welcome to apply at early access in this link here. So what do our customers say about us? They love the high performance for speech recognition in terms of its low latency. And at the same time, it's very easy to integrate with their current workflow for optimized throughput latency deployment for production ready environment. They also appreciate the multimodality feature alongside with all the AI services that Jarvis has to offer. And then at the same time, there's the sample application make it easy to get it started. So now with that said, we would love to get into understanding on how can we build an application using Jarvis ASR and TTS, and then leveraging Rasa's Dialog Manager and NLU. So Nikhil, I will hand it over to you. So please walk us through how you set this up and then different components that you have leveraged.
Thank you, Alex. So let me just quickly share my screen. Hi. So I'll be talking about Jarvis Rasa demo application, a weather chatbot that we have built. So we recently decided to start this integration project with the goal of learning how much effort a developer should have to put in to integrate Jarvis ASR and TTS on a chatbot built with Rasa. And we found that the answer as of today is that it doesn't take a lot of effort to actually go ahead and integrate Jarvis and Rasa. And the benefit is that you have a more natural interaction with the chatbot. So this is clearly a starting point, and the simple system we are going to see today has the goal of showing how easy the integration is between Rasa Dialog Manager, Rasa NLU, Jarvis TTS, and Jarvis ASR. So the weather chatbot is built as a web application. We've also added a component to the web UI that shows what is going on under the hood of the system in real time. But this piece of functionality is still under development. Okay. So let me describe the system to you in this version that we have, in this implementation that we have. First, we ran a Docker container with Rasa functionality exposed over API endpoints, and this is deployed on a system with GPUs for performance. We also have Jarvis AI services up and running on another container, and this functionality is exposed via gRPC endpoints. And finally, we have the client application that we deployed with the container running the UI. And this is responsible for pipelining the ASR, TTS, NLP, and DM functionalities. And this does not need GPUs. Okay, so now let's take a look at the architecture. So on the left side, we have the user that interacts with the system through his voice and receives answers through the speakers, right? So to go into the details of this pipeline, the question spoken by the user gets transcribed by a call to the Jarvis ASR service. The text goes to the Rasa wrapper, which in turn makes an API call to Rasa DM and Rasa NLU to decide what the next appropriate action is. The client is also responsible for fulfillment when needed. The reply of the bot goes to TTS, Jarvis, and this will speak the response back to the user. As you can see, both Jarvis AI services and Rasa are deployed on GPUs for better performance. You can see that on the right side of the diagram here. Okay, so now that we know the architecture, let's take a more technical look under the hood. First, let us take a look at the folder structure of the client application, i.e. our chatbot. So the most important files to look at here are asr.py, rasa.py, tts stream.py, tts.py, and finally chatbot.py at the bottom. So we'll be going through these files in some detail in the next few slides. Okay, so let's start with chatbot.py. Right? This is the file that contains the chatbot class. We have one chatbot per conversation, and this is responsible for handling all ASR, TTS, and Rasa operations for that conversation. So if you look to the left, when an instance of the chatbot class gets created during its initialization, we create instances of ASR, Rasa, and TTS classes. First, let's talk about ASR. Here we use ASR in streaming mode as opposed to batch mode. What does that mean? Well, we can either wait for the user to finish talking and then process all that audio at once, or we can keep streaming the audio as the user is talking and keep recognizing this text. Here we do the latter, which is called as streaming ASR. So streaming ASR is a background process and keeps happening throughout as long as the website is open. So if you look at the code snippet on the right, you will see ASR fill buffer function. So this function in turn calls ASR instances fill buffer function. So we simply keep adding our audio stream to the ASR buffer through this function, and and then automatically Jarvis ASR gets called, and we keep transcribing the audio. At the bottom, you will see the Rasa TTS pipeline. This function is responsible for pipelining the Rasa and Jarvis TTS functionality. As you can see, it first calls the Rasa instances request Rasa for question function. It gets the response from Rasa, which is in text format, and then fills the TTS buffer the same way we were filling the ASR buffer before. It also returns this Rasa textual response. As you can see here, we can easily pipeline the Rasa and TTS functionality into one function. I've already covered how we get the audio into the ASR buffer. Now, once we have the audio, we use main_ASR function to generate the transcript. We first import the Jarvis client libraries, as you can see from the code snippet at the top. Okay, so for those who are familiar with Rasa know that Rasa is exposed over REST API endpoints, and you can simply use the request library to query the Rasa server. But in the case of Jarvis, Jarvis exposes gRPC endpoints, right? And to access these gRPC endpoints, you also need to have a few Jarvis client libraries installed on the client container, right? So these are the libraries that I'm importing at the top here. Okay, so then we go to the main ASR function. We first set some configuration parameters like the language, the number of channels, the audio encoding, sample rate, etc. And then we use the generator to iteratively call streaming recognize request function with the audio clip. So this returns a stream of text inputs, text transcripts, and we return the final text transcript from here. Now over to Rasa.py. So this code snippet shows the main function of this class. It takes the user input as text, calls Rasa with this text and sender ID using the exposed Rasa APIs using the request library. It then gets the response back from Rasa and returns a processed version of this response. Okay, so tts.py and ttsstream.py. So like ASR, TTS can either be used in batch mode or streaming mode. With batch mode, we take all the text at once and generate audio, whereas in streaming mode, we stream text and generate a stream of audio, right? So the only difference between these two files is in the way that we handle TTS, whether it's batch or stream. Okay, so as in ASR, we first import the Jarvis TTS client libraries. You can see the code snippet at the top for that. And again, as in ISR, here we rely on the get speech function to actually perform TTS. And we first set some config parameters, right? Like language, sample rate, and the name of the voice that we want. So here, the voice is the same voice that we saw earlier. It's the voice of Misty. So, okay, so then we start TTS streaming by calling synthesize online function. We loop over this response and yield audio output in chunks of configurable duration, resulting in streaming audio output. Okay, so now let's move on to the demo. So while the demo plays, please take a note of the high accuracy and low latency for both ASR and TTS operations. Also note that there is background noise in the video on purpose, but ASR performs well in spite of this. Okay, here's the video.
How is the weather
For which location?
in London?
It is clear in London at the moment. The temperature is 16 degrees, the humidity is 77%, and the wind speed is 7 miles per hour.
Is it raining in Los Angeles?
It is sunny in Los Angeles at the moment. The temperature is 22 degrees, the humidity is 66%, and the wind speed is 0 miles per hour.
Is it hot in Austin?
It is clear in Austin at the moment. The temperature is 26 degrees, the humidity is 74%, and the wind speed is 0 miles per hour.
Okay, that was the video demo that we had for you. Back to you, Alex.
Yeah, thanks. Yeah, thank you everyone for your attention, and I hope this is helpful to see how we can actually create a speech-based virtual assistant using Rasa Dialogue Manager and Out on You, and also leverage Jarvis ASR and TTS. Couple of things you might have noticed that there's some background noise, and then that doesn't impact the ASR transcription accuracy, and then you can see also the latency response, the very low latency response definitely helped with the end user experience instead of waiting a lag to have the answer back. So yes, so if you're interested in checking out what Jarvis Early Access has to offer, and we highly encourage you to join us in this link through developer.nvidia.com, NVIDIA Jarvis Early Access, and we hope to come across paths in the near future. Thanks, everyone.